Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at a proof by contradiction. So a proof by contradiction is pretty much basically saying the opposite of the statement and proving that is incorrect or basically impossible pretty much. So we'll be taking a look at this statement here. So suppose that 3 to the power x is equal to 2. Prove that x is irrational. Okay, so first of all, we need to understand what rational and irrational is before we even start this proof. So rational means something can be represented as a fraction. So for example, if we think of like let's go 18 over 27. That's the same as 2 over 3 because you can break 18 up into 9 times by 2 and 27 into 3 times by 9. So you can cancel out that 9. So you can represent that as a fraction. You can also represent, let's go 1 as a fraction. It's 1 over 1. Or 2 as 2 over 1. Or any number pretty much. Numbers like pi, like 3.14 dot 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 dot, or e 2.71 dot 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 dot, they cannot be represented as a fraction because they are irrational. They are basically an infinite number that doesn't have a single pattern to it pretty much, okay? So pretty much we're looking at this thing here and we need to pretty much prove that x is irrational. So proof by contradiction is, let's say, alright, let's try and prove x is rational, and let's see if we can find a contradiction, because as soon as we find a contradiction we know that x is not rational, and that means the other statement must be true, that x is irrational. Okay, so prove that x is rational. So if x is rational, that x can be represented as a fraction. So let's just go m divided by n. Okay, now m and n are integers. Okay, so m and n are integers that cannot be represented any other way. So basically they have no common factors, so no common factors, and this is the most simplified form, so no common factors, most simplified expression. Okay, so all we start to do is pretty much we're just going to substitute this into our formula up here. So pretty much we'll get 3 to the power of m over n equals 2. Okay, now what we want to do is we want to break up this fraction and we want to move one of the letters to the other side. So the best way to do that is pretty much to move the n by raising both sides to the power of n. So if we do that on both sides, this is what we're going to get. So if I do that, raise to the power of n, and I raise this to the power of n. Using my index law, so if you have a to the power of n to the n, that is the same as a to the power of m times by n. So when we distribute it here, what we get is 3 to the power of m over n times by n is equal to 2 to the power of n. You can see straight away that n cancels out, so you get 3 to the power of m. So 3 to the power of m is equal to 2 to the power of n. Now, m and n are integers. So looking at this statement, can you see what's wrong here? If you take a whole number, or an integer, and you put it to the power of an odd number, so let's go odd to the power of an integer, that result will always be odd. Okay, so for example, 3 squared gives you 9, that's odd. 3 cubed is 27, that's still odd. And same here, if you go an even number, so even to the power of an integer, it's still going to be even. So for example, 2 squared is 4, 2 to the power of 3 is 8, they're always even results. So no matter what integer you have for m or n, this result is always going to be odd, and this result is always going to be even. Now, an even number cannot equal an odd number. That is the contradiction in this statement. So if an even equals an odd, that means we have a contradiction. So since there is a contradiction, so we just go contradiction, as an odd can equal an even, therefore we can just say x is irrational. X is irrational. Let's see if I can spell that right actually. Oh, there we go, it's up there. Irrational. And that's it, pretty much. That's a proof by contradiction for this example here. I hope you enjoyed it. If you learned something, leave a comment, like, and subscribe, and I'll see you in the next one.